the most iconic feature of the solar system, is currently in the process of vanishing. Saturn is the sixth planet from the Sun and the second largest in our planetary neighborhood. While several gas giants possess ring systems, Saturn's rings are the most extensive and visible, composed of billions of chunks of water ice and rock. Recent data suggests that these structures are not permanent fixtures, but temporary ornaments that are rapidly draining away into the planet's interior. Scientists view the disappearance of Saturn's rings as a critical opportunity to understand the life cycle of planetary matter. For decades, the age of the rings was a subject of intense debate, with some arguing they formed alongside the planet 4 billion years ago. By measuring the rate at which the rings are currently decaying, researchers can work backward to determine their origin. This helps establish whether such rings are a common short-lived phase for all large planets or a rare occurrence triggered by a specific cosmic event. The destruction of the rings is a result of a process known as ring rain. This phenomenon is driven by a complex interaction between solar radiation, gravity, and magnetism. To understand how a massive ring system evaporates, one must look at the specific mechanical steps occurring at the microscopic level. The process begins with the sun. Ultraviolet light from the sun hits the tiny particles of ice that make up the rings. This light knocks electrons off the ice, giving the particles an electric charge. In the vacuum of space, these charged particles become susceptible to the influence of Saturn's powerful magnetic field. Once charged, the ice particles are no longer governed solely by the momentum of their orbit. Saturn's magnetic field lines act like invisible tracks, curving inward toward the planet's atmosphere. The planet's gravity then pulls these electrified specks of ice down along those magnetic tracks. As the ice falls into the upper atmosphere, it vaporizes. This creates a constant, invisible downpour of water that chemically interacts with Saturn's ionosphere. The consequence is a staggering loss of mass. Data from the Cassini mission suggests that every half hour, an amount of water equivalent to the volume of an Olympic-sized swimming pool drains out of the rings and into the planet. Beyond this rain, there is a secondary force at play involving the ring's inner edges. Because the innermost rings orbit so close to the planet's atmosphere, they are subject to atmospheric drag. Even in the thin upper reaches of Saturn's gas envelope, there are enough stray molecules to create friction. This friction slows the orbital speed of the ice, causing it to spiral inward and eventually vanish into the depths of the gas giant. The combined effect of these forces is a definitive expiration date for the rings. While the structure appears solid from a distance, it is actually a delicate balancing act that is now tilting toward total collapse. Our understanding of this event is bounded by the data gathered during the grand finale of the Cassini spacecraft in 2017. We know for certain that the rings are losing mass at a rate that will lead to their total disappearance in approximately 100 to 300 million years. While this sounds like a vast duration, in the context of a planet that is 4 billion years old, it represents a very brief window of time. We also know for certain that the rings are much younger than previously thought. Based on their brightness and lack of accumulated space dust, evidence indicates the rings likely formed between 10 and 100 million years ago. This means that when dinosaurs first appeared on Earth, Saturn may have looked like a plain yellow sphere without its signature halo. There are aspects of this process that remain theoretical. While we can measure the rate of decay, we do not yet have a confirmed explanation for how the rings were created. One lead-in theory suggests a medium-sized icy moon wandered too close to Saturn and was torn apart by tidal forces, the stretching effect of gravity. Another theory proposes a massive collision between two moons that shattered them into the billions of pieces we see today. Without a physical sample of the ring material, these scenarios remain the subjects of ongoing computer modeling. It is important to debunk the myth that the rings are solid disks. If a person were to fly a spacecraft through the rings, they would not see a continuous sheet of material. They would see a vast, nearly empty space populated by independent chunks of ice, most of them the size of a grain of sand, with occasional boulders the size of a house. The rings are essentially a massive flat cloud of debris. Another common misconception is that the rings will disappear suddenly. The decay is a gradual mathematical thinning. Over millions of years, the gaps between the rings will widen, and the outermost sections will fade until the planet eventually returns to its original ringless state. From a human perspective, the current state of Saturn is a matter of profound timing. If human civilization had emerged a few 100 million years earlier or a few 100 million years later, the night sky would look fundamentally different. We happen to exist during the brief interval where Saturn is wearing its rings. In the cosmic scale, Saturn's disappearing rings serve as a calm reminder of the impermanence of the universe. We often view the planets as static, unchanging spheres, but they are dynamic systems in constant flux. The rings are a reminder that the solar system is still evolving and that beauty in space is often a byproduct of destruction and decay. The observation of ring rain teaches us that gravity and magnetism are always at work, quietly reshaping the architecture of the heavens. Saturn is not losing its identity. It is simply moving into a new phase of its existence. We are merely the silent observers of a transformation that began long before us and will continue long after we are gone. The story of Saturn's rings is a testament to the fact that even the most massive and beautiful structures are subject to the same laws of physics that governs a drop of rain on Earth. The rings are vanishing, but in their disappearance, they are revealing the true history of our solar system and the temporary nature of all we see in the stars.